Now in this lecture we'll answer on two questions. In the first question we'll find out the length of line segment X, and in the second question we'll find out the shaded area that is inside this quarter circle. So we'll start with the first question. In the drawing we have triangle ABC. We know that angle ABC, this angle equals to 30 degrees. Angle ACB, this angle equals also to 30 degrees. And inside triangle ABC we have another triangle ADE and angle DAE. This angle equals to 60 degrees. And we also know that line segment BD equals to 5 units. Line segment EC, this line segment equals to 4 units. And we want to find out the value of line segment DE that is equal to X. Okay, so first of all, we'll focus on triangle ABC. In triangle ABC, we have those two angles that are equal to each other. So I'll write it down. We actually know that angle ABC, this angle, angle ABC equals to 30 degrees, and it is equal to angle ACB that is also equals to 30 degrees. So I repeat again, in triangle ABC, we know that angle ACB equals to angle ABC, and both angles they are equal to 30 degrees. And according to the rule that in front of equal angles in the triangle there are equal sides, that is to say, in front of this angle we have side AB, and in front of this angle we have side AC, and according to the rule that I mentioned, side AB equals to side AC. Okay, side AB equals to side AC. And we also we will define angle BAD as alpha, and we will define angle EAC, this angle, as beta. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and especially the sum of the angles in triangle ABC must be equal to 180 degrees. So which angles we have in triangle ABC? We have this angle that is equal to 30 degrees, plus this angle that is also equal to 30 degrees, plus this angle that is equal to alpha, plus this angle that is equal to 60 degrees, plus this angle that is equal to beta according to our definition. In total, the sum of those angles must be equal to 180 degrees. Okay. The sum of the angles in triangle ABC equals to 180 degrees. So here we have 30 degrees plus 30 degrees is 60 degrees, and 60 degrees plus 60 degrees is 120 degrees, plus alpha plus beta equals to 180 degrees. Okay. Here we subtract 120 degrees from this equation, and we get that alpha plus beta equals to 180 degrees minus 120 degrees is 60 degrees. So we found out that alpha plus beta equals to 60 degrees. In the next step, we'll do a construction. Here we will, from point A, we'll draw a straight line in such a way that the angle CA and the straight line will create here angle alpha. Okay, so here this angle CA with the straight line equals to alpha according to our construction. In addition, from point C, we'll draw a straight line in such a way that the straight line with side CA will create angle of 30 degrees. So this angle is equal to 30 degrees according to our construction. And in the next step, we will extend the straight line from point C until it intersects with the other straight line. And we will define the touching point of the two straight line, or the intersection point of the two straight line that we constructed as point F. So here we created triangle ACF. In the next step, we will prove, we already proved that AB equals to AC. In the next step, we will prove that triangle ABD, this triangle, is congruent to this triangle, triangle AFC. So why those two triangles congruent to each other? First of all, those two angles, they are both equal to alpha, and therefore they are equal to each other. This angle equals to alpha according to our construction. So we can write down that angle BAD, this angle, equals to this angle that is actually angle CAF, and both angles are equal to alpha, therefore they are equal to each other. Okay, repeat again, angle BAD equals to angle CAF equals to alpha. In addition, we have already proved that side AB equals to side AC. So we can write down that AB equals to AC, and finally those two angles, they are both equal to 30 degrees, therefore they are equal to each other. So here angle ABD, this angle, equals to this angle that is actually angle ACF, and both angles are equal to 30 degrees, therefore they are equal to each other. So I'll repeat again, angle ABD equals to angle ACF, they are both equal to 30 degrees, therefore they are equal to each other. Actually, we proved that triangle ABD congruent, this is the sign of congruent, to triangle AFC according to angle side angle rule. I repeat again, those two triangles can go into each other according to angle side angle rule. We have those two angles and the side that attach to them, that is to say side AB and triangle ABD, congruent to those two angles and the side that attach to them, that is to say side AC and triangle AFC. Therefore, those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we conclude two things. The first thing is side BD equals to side FC. Side BD equals to side FC according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say BD and FC, must be equal to each other. But according to what is given as the question, BD equals to 5 units. So you can write here that BD equals to 5, and from this equation 5 equals to BD equals to FC, we'll conclude that FC is also equals to 5 units. Okay, here FC equals to 5 units also. In addition, we conclude from the fact that those two triangles can go into each other that side AD equals to side AF. Side AD equals to side AF according to the same rule that corresponding sides in congruent triangles are equal to each other. Here, side AD equals to side AF. So, and if we define side AD as A, that is to say here side AD equals to A, then according to this equation A equals to AD equals to AF, we derive that side AF is also equals to A. So we found out that side AF equals to A. Okay. In the next step, we'll join points E and F together by a straight line. We have already found out that alpha plus beta equals to 60 degrees. So this angle EAF, that is equal to alpha plus beta, is equal to 60 degrees. Okay, it is equal to 60 degrees. Now we'll prove that the green triangle ADE congruent to the orange triangle AEF. So why those two triangles can go into each other? So we'll prove that the green triangle ADE congruent to the orange triangle AEF. So why the green triangle congruent to the orange triangle? First of all, we found out that those two sides, they are both equal to A, therefore they are equal to each other. So side AD equals to side AF equals to A. Okay, side AD equals to side AF equals to A. In addition, those two angles, they are both equal to 60 degrees, therefore they are equal to each other. So angle DAE, this angle equals to this angle, this is actually angle EAF. and they are both equal to 60 degrees, therefore they are equal to each other. I'll repeat again. Angle DAE equals to angle EF. They are both equal to 60 degrees, therefore they are equal to each other. And finally, we have side AE, that is a common side, it belongs to both triangles, so side AE equals to itself. It's a common side, it belongs to both triangles. Okay, side AE equals to side AE. It's a common side that belongs to both triangles. Actually, we proved that the green triangle, triangle ADE, congruent to the orange triangle, triangle AEF, according to side angle side rule. Repeat again. We proved that the green triangle, triangle ADE, can point to the right triangle, triangle AEF, according to side angle side rule. We have in the green triangle those two sides and the angle between them in the green triangle congruent to those two sides and the angle between them in the orange triangle. Therefore, those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we conclude that side DE equals to side EF. DE equals to EF according to the rule that corresponding sides in congruent triangles are equal to each other. So DE equals to EF, but according to what is given in the question, DE equals to X. You can write down that DE equals to X, and from this equation X equals to DE equals to EF, we will derive that side EF is also equals to X. Side EF is also equals to X. In the next step, I will present to you the law of cosines, and we will implement the law of cosines in this triangle, triangle EFC. So, what is the law of cosines? The law of cosines is true in any triangle. So we can write down that in any triangle, here this triangle, triangle ABC could be any triangle. This is triangle ABC. And we know that side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is theta. Then, according to the law of cosines, in triangle ABC, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. I'll repeat again. In any triangle, and this here triangle ABC could be any triangle, so in any triangle, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. And Now we will implement the law of cosines in triangle EFC. So I copy triangle EFC here, and we'll implement the law of cosines in this triangle EFC. Angle ECF, this angle equals to 30 degrees plus 30 degrees. So I copied triangle EFC here. So according to the law of cosines, we will implement the law of cosines in this triangle EFC. So according to the law of cosines, we get that in triangle EFC, x squared equals to 4 squared plus 5 squared minus 2 times 4 times 5 times cosine 60 degrees. Okay. Repeat again, x squared equals to 4 squared plus 5 squared minus 2 times 4 times 4 times cosine 60 degrees. So here we found out that x squared equals to 4 squared is 16 plus 5 squared is 25 minus 2 times 4 times 5 is 20, and 20 times minus 2 is minus 40. Cosine 60 degrees is 1 half. So in conclusion, we found out that x squared equals to 16 plus 25 is 41, and minus 40 over 2 is minus 20, and 41 minus 20 is 21. So in conclusion, we found out that x, we take a root out of this equation, and we get that x equals to the positive square root of 21, or in terms of numbers, it is equals to 4.58 units. Okay. So here we found out that x equals to the positive root of 21, or in terms of numbers it is equal to 4.58 units. D equals to x equals to either the positive root of the positive square root of 21, or in terms of numbers it is equal to 4.58 units. So we finished with the first question. In the next step I will present to you the second question. In the drawing, we have a counter circle. This is a counter circle. Inside the counter circle, we have a semicircle and a circle. The semicircle is tangent to the circle at this point, and this circle is tangent to the quarter circle at this point. And our mission is to find out the shaded area. Okay, so first of all, because of the fact that this is a quarter circle, it means that this point is the center of the quarter circle. So we'll define the center of the quarter circle as point O, and this angle equals to 90 degrees. It is a right angle. Okay. We define this point as point B. So here tangent OB is tangent to this circle at point M. Point M is the point of tendency. Of tangent OB with this circle. And we define the center of this circle as point P. We define the center of the semicircle as point H. We define this point as point C, and we define this point as point D. And here we actually have, we know that PM is the radius of this circle, and we have here rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent AB to this circle is point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM that is drawn to the point of tendency. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. So if AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we actually can implement rule number 1 in our drawing, because we have here the radius PM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent OB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius MP. So if OB is perpendicular to MP, it means that this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. In the next step, from point P, that is the center of the circle, we will draw perpendicular on CO. So from point P we draw perpendicular on CO or DO. So actually this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point P and DO as point S. So actually, we created here quadrilateral SPOM. Inside quadrilateral SPOM, we have 1, 2, 3 right angles. Repeat again. Inside quadrilateral SPOM, we have 1, 2, 3 right angles. And we know that the sum of right angles is 90 times 3 is 270 degrees. $270 plus the size of the fourth angle, that is actually angle SPM, this angle. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, the sum of those four angles equals to 360 degrees. So here we subtract 270 degrees from this equation, and we'll get that the missing angle, angle SPM, equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So it is actually a right angle is equal to 90 degrees. Angle SPM equals to 90 degrees, it is a right angle. So actually we found out that all the angles inside quadrilateral SPOM are right angles. Quadrilateral SPOM has 4 right angles, and therefore any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral SPOM as a rectangle, because it has 4 right angles. So quadrilateral SPOM is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle SPOM, they are equal to each other. That is to say, PM equals to SO. PM equals to SO, according to the rule that the opposite sides of a rectangle are equal to each other. But we know that PM equals to 2 units. It is the radius of the circle. So we can write here that PM equals to 2. And from this equation, 2 equals to PM equals to SO, we derive that SO is also equals to 2 units. SO is also equals to 2 units. Here we can write down that SO equals to 2 units. In addition, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that OM equals to SP. OM equals to SP. So if we define OM as X, so here OM equals to X according to our definition, then from this equation X equals to OM equals to SP, we derive that SP is also equals to X. So here SP is also equals to X. Okay, so we know according to the drawing, this circle has an internal notch between the quarter circle and this point. This is the touching point or the point of tendency between the quarter circle and the circle. So we define the touching points of the circle and the quarter circle as point K. So the circle and the quarter circle have an internal notch between them, it's point K, and whenever you have two circular shapes that have an internal notch between them, then the straight line that joins their centers must pass through the point of tendency or through the touching point of the two circles or semicircles or two circular shapes. So here you know that the center of the quarter circle is point O, the center of the circle is at point P, and according to the rule that I mentioned, the straight line OP that connects the two centers together must pass from the touching point of the two circular shapes, that is to say, it must pass from point K. Okay? Or in other words, OPK is one straight line. According to the rule that I mentioned, line segment OPK is one straight line. Okay? And we know that P is the center of the circle, K is a point on the circle itself, therefore PK is the radius of this circle that is equal to 2 units. So, if OPK is a straight line, it means that OK is also a straight line. And what is the definition of line segment OK that is a straight line? Point O is the center of the quarter circle. Point K is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OK that is a straight line, it is also the radius of the quarter circle. OK is the radius of the quarter circle. So we define the radius of the quarter circle is capital R. So according to our definition, OK, that is the radius of the circle, of the quarter circle, equals to capital R. We have already found out that PK equals to 2, it is the radius of the circle. So what is the value of line segment PO? The value, it is very easy to see from the drawing that the value of line segment PO equals to OK minus PK. Again, OK minus PK equals to PO. So it is OK minus PK. I repeat again. From the drawing, it is very easy to see that PO equals to OK minus PK. So that is to say, PO equals to OK, that is the radius of the quarter circle, that is equal to capital R, minus PK, that is the radius of the circle, that is equal to 2. So in conclusion, we found out that PO equals to R minus 2. So you can write down here that the drawing that PO equals to capital R minus 2. Now we'll implement the Pythagoras theorem. We'll implement the Pythagoras theorem on the right triangle, triangle OPM. So I will copy the right triangle OPM in the new page and we'll implement the Pythagoras theorem on this triangle, triangle OPM. Okay. This is the right triangle, triangle OPM that I copied from the original drawing. In the right triangle, triangle OPM, you know that PM equals to 2 units. This is the radius of the circle. We just found out that the hypotenuse OP equals to capital R minus 2. And OM equals to X. So here, by PT is abbreviation for Pythagoras theorem. In the right triangle OPM, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this will be equation number 1. The hypotenuse is OP, so the square of the hypotenuse is OP squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PM squared plus OM squared. Okay, I repeat again, according to the Pythagoras theorem, OP squared equals to PM squared plus OM squared. OP equals to R minus 2, so OP squared is R minus 2 squared. That is equal to PM squared. PM is 2, so PM squared is 2 squared, that is 4, plus OM squared. OM is X, so OM squared is X squared. So in conclusion, we found out that according to equation number 1, R minus 2 squared equals to 4 plus X squared. Here we'll open the brackets on this side of equation number 1 and we'll get that R minus 2 squared equals to R squared plus 2 squared, that is 4, minus 2 times R times 2, that is minus 4. That is equal to 4 plus X squared. So here, in equation number 1, we have 4 on both sides of the equation, so 4 will get cancelled. What is left from equation number 1 after we cancelled 4? We have here, according to equation number 1, X squared equals to R squared minus 4R. So, repeat again, according to equation number 1, we found out that X squared equals to R squared minus 4R. Okay. Here, this circle have an external lunge between the semicircle and this point. Okay. This is the touching point between the semicircle and between the semicircle and the circle. So we define the touching point of the semicircle and the circle as point L. And we have another rule that says that whenever two circular shapes have an external length between them, like in this drawing, those two circle and semicircle touching each other externally is point L. Then the straight line that joins their centers, that is to say point P is the center of the circle, point H is the center of the semicircle, and the straight line that joins their centers together is PH. And according to the rule that I mentioned here, the straight line PH must pass for the point of tendency, that is to say it must pass for point L. That is to say PLH is one straight line. Okay, so here PLH is one straight line. I'll repeat again. According to the rule that I mentioned, line segment PLH is one straight line. Okay, line segment PLH is one straight line. So here point P is the center of the circle, point L is a point on the circle itself. So this is exactly the definition of a radius, that is to say PL is the radius of this circle, that is equal to 2 units. Okay, likewise we have here point H is the center of the semicircle, point L is a point on the semicircle itself. So HL is the radius, of the semicircle. According to what is given in the question, the radius of the semicircle is also equals to 2 units. So HL equals to 2. Okay. And we know that PLH is one straight line. That is to say, PH is a straight line. PH is a straight line. So the straight line PH, according to what we found out, the straight line PH or HP equals to HL plus HP. So the straight line HP equals to HL plus LP. So HP equals to HL, that is 2, plus LP, that is also 2. So HP equals to 2 plus 2, that is 4. So HP equals to 4 units. So in the next step I will copy the right triangle edge SP or PHS in a new page, and we will implement the Pythagoras theorem on the right triangle PHS. Okay. Angle PSH equals to 90 degrees according to our construction. We've already found out that HP equals to 4 units. The hypotenuse HP equals to 4 units. And what is the value of edge S? The value of line segment edge S, from the drawing it is very easy to see that edge S equals to CO, that is the radius of the quarter circle, minus C edge minus SO. I'll repeat again. Side edges of the right triangle edges P equals to CO, that is the radius of the quarter circle, that is equal to capital R, minus C edge. What is the value of C edge? Edge is the center of the semicircle. C is the point on the semicircle itself. This is exactly the definition of a radius. That is to say, C edge equals to 2 units. So, edge S, side edge S of the right triangle edges P equals to CO, that is the radius. So it is equals to capital R, the radius of the quarter circle, minus C edge. We just now found out that C edge equals to 2 units, minus SO. Here, SO equals to 2 units. Okay, so it is minus 2. So in conclusion, we found out that edge S, side edge S of the right triangle edges P equals to R, capital R, minus 2 is minus 4. So in conclusion, it is equals to capital R minus 4. Edge S equals to capital R minus 4. Edge S equals to capital R minus 4. Okay, so you can write here that edge S equals to capital R minus 4. Now we implement the Pythagoras theorem in the right triangle, triangle edges P. According to the Pythagoras theorem, in the right triangle edges P, by PT is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is HP, so the square of the hypotenuse is HP squared. It must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to edge S squared plus SP squared. Okay, repeat again, in the right triangle edges P according to the Pythagoras theorem, HP squared equals to edge S squared plus SP squared. HP equals to 4, so HP squared is 4 squared, that is 16. That is equal to edge S squared. Edge S equals to capital R minus 4, so edge S squared is capital R minus 4 squared plus SP squared. SP equals to X, so SP squared is X squared. So here we'll open the brackets on this side of equation number 2 and we'll get that 16 equals to R minus 4 squared equals to R squared plus 4 squared, it is 16, minus 2 times r times 4 is minus 8r, plus x squared. So here we have 16 on both sides of equation number 2, so 16 will get cancelled. What is left from equation number 2 after we cancelled 16? What is left is that in this side we have 0, that is equals to r squared minus 8r plus x squared. So we'll add 8r to this equation, equation number 2, and we get that according to equation number 2, 8r equals to r squared plus x squared. Here we subtract r squared from this equation, equation number 2, and we get that according to equation number 2, x squared equals to 8r minus r squared. Okay? So we actually have two expressions for x squared. According to equation, the first equation, equation number 1, we found out that x squared equals to r squared minus 4r, while according to equation number 2, we found out that x squared equals to 8r minus r squared. Now we create equation number 3 that states that x squared according to equation number 1 must be equal to x squared according to equation number 2. Okay, so x squared according to equation number 1 is equal to r squared minus 4r, while x squared according to equation number 2 equals to 8r minus r squared. So according to equation number 3, we found out that r squared minus 4r equals to 8r minus r squared. Here we add r squared to this equation, equation number 3, and we get that according to equation number 3, r squared plus r squared is 2r squared minus 4r equals to 8r. So here we add 4r to this equation, equation number 3, and we get that according to equation number 3, two r squared equals to 12r. Here we divide this equation, equation number 3 by 2, and we get that according to equation number 3, r squared, 2r squared over 2 is r squared, and r squared equals to 12r over 2 is 6r. So I found out that r squared equals to 6r. And according to equation number 3, here we will subtract 6r from this equation, equation number 3, and we get that according to equation number 3, r squared minus 6r equals to 0. So here we take a common factor of r from this equation, equation number 3, and we get that according to equation number 3, r, what left from this expression after we took from it r, a second factor, what is left, it is actually r, and what is left from minus 6r after we took from it r, a second factor, what is left, it is actually minus 6. So in conclusion, we found out that r times r minus 6 equals to 0. So here we have two solutions that are possible for r. The first solution is r equals to 0, but because of the fact that r is the radius of this quarter circle, it must be a positive number, so it can never be equal to 0. So we cancel this solution, and we left only with the other solution that r minus 6 equals to 0. If r minus 6 equals to 0, here we add 6 to this equation, and we get that r equals to 6 units. So we found out that the radius of this quarter circle equals to 6 units. So what is the area of the what is the value of the shaded area? It's very easy to see from the drawing that the value of the shaded area is equal to the area of the quarter circle minus the area of the circle minus the area of the semicircle. Repeat again. The shaded area equals to the area of the quarter circle minus the area of the circle minus the area of the semicircle. In the area of the quarter circle, we know that the radius of the quarter circle equals to 6, and the area of the quarter circle is the area of the circle over 4, and the area of the circle is pi r squared over 4. Pi, the area of the circle is pi r squared, and the area of the quarter circle will be equal to pi r squared over 4 minus the area of the circle. We know that the radius of the circle equals to 2, so the area of the circle is pi r squared, and r equals to 2, so it is pi times 2 squared minus the area of the semicircle. The area of the semicircle equals to the area of the circle over 2. That is to say, it is equal to pi r squared over 2, and r equals to 2, so it is pi 2 squared over 2. The area of the semicircle equals to pi 2 squared over 2. We have already found out that the radius of the quarter circle equals to 6 units, so capital R equals to 6, and 6 squared is 36. So the area of the quarter circle equals to 36 pi over 4 minus the area of the circle, that is equal to 2 square times pi. 2 square is 4, so, and 4 times pi is 4 pi. So the area of the circle equals to 4 pi square units, while the area of the semicircle equals to pi 2 square over 2. 2 square is 4, 4 over 2 is 2, and 2 times pi is 2 pi. So in conclusion, the area of the semicircle equals to 2 pi. So here 36 over 4 is 9. So in conclusion, the area of the quarter circle equals to 9 times pi, that is 9 pi, minus the area of the circle, that is 4 pi, minus the area of the semicircle, that is 2 pi. Here 9 pi minus 4 pi is 5 pi, and 5 pi minus 2 pi is 3 pi. So in conclusion, we found out that the value of the shaded area, the value of this shaded area equals to, the value of the shaded area equals to either 3 pi square units, or in terms of numbers, it is equals to 9.42 square units. I'll repeat again. The value of the shaded area here equals to either 3 pi square units, or in terms of numbers, it is equal to 9.42 square units. So we finished with the second question. In the next step, I will summarize the lecture. We'll start with the first question. So in the drawing we have triangle ABC. We know that those two angles are both equal to 30 degrees. Side line segment EC equals to 4 units, line segment BD equals to 5 units. Angle DAE equals to 60 degrees, this angle, and we want to find out the value of line segment DE that is equal to x according to what is given us in the question. So first of all, if we focus on triangle ABC, we know that those two angles are equal to each other. So in triangle ABC, angle ACB equals to angle ABC, and both angles are equal to 30 degrees. And according to the rule that in front of equal angles in the triangle there are equal sides, we get that side AB equals to side AC because of the fact that those two sides are located between the two equal angles. So AB equals to AC. We define angle BAC as alpha, angle EA. Yeah, we define angle EA. We define angle BAD as alpha and angle EAC is beta. And we know that the sum of the angles in any triangle equals to 180 degrees, and especially the sum of the angles in triangle ABC, it is equal to 180 degrees. So which angles we have in triangle ABC? We have here 30 degrees, plus 30 degrees, plus angle alpha, plus 60 degrees, plus angle theta. In total, they must be equal to 180 degrees. 30 degrees plus 30 degrees is 60 degrees, and 60 degrees plus 60 degrees is 180 degrees. So in conclusion, in this side of the equation, we have 120 degrees plus alpha plus beta, and on the other side of the equation, we have 180 degrees. We subtracted 120 degrees from this equation and found out that alpha plus beta equals to 180 degrees plus 120 degrees equals to 60 degrees. Then we did the construction. From point A, we drew a straight line in such a way that this angle will be equal to alpha. That is to say, angle CA and the straight line that we drew, they will make this angle that will be equal to alpha. So this angle CAF equals to alpha according to our construction. And we did another construction from point C. We draw a straight line in such a way that angle ACF will be equal to 30 degrees. Okay, so angle ACF equals to 30 degrees according to our construction. Then we extended the straight line from point C until it intersects with the other straight line at point F. Point F is the intersection point or the touching point of the two straight lines that we constructed. So in this way we created triangle AFC, and we proved that those two triangles can go into each other. Why those two triangles can go into each other? That is to say, triangle ADB can go into triangle AFC. Why those two triangles can go into each other? First of all, here we have those two angles that are both equal to alpha, therefore they are equal to each other. In addition, AB equals to AC. We have already found out that AB equals to AC because those two sides in triangle ABC are located in front of equal angles, therefore they are equal to each other. So AB equals to AC. And finally, those two angles that are both equal to 30 degrees, therefore they are equal to each other. So we actually proved the triangle ABD can go into a triangle AFC according to angle side angle rule. Here, those two angles and the angle and the side that attach to them, that is to say AB in triangle ABD can go to those two angles and the side that is attached to them that is AC in triangle AFC. Therefore, those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we'll conclude that BD equals to FC. Side BD equals to side FC according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides BD and FC must be also equal to each other. Okay, here BD equals to FC. But according to what is given as the question, BD equals to 5 units. So we can write here that BD equals to 5. And from this equation, 5 equals to BD equals to FC. We derive that FC also equals to 5 units. Here, FC also equals to 5 units. Okay. In addition, from the fact that those two triangles can go into each other, we actually concluded that side AD equals to side AF. Side AD equals to side AF according to the same rule that corresponding sides of congruent triangles are equal to each other. So if we define side AD as A, here AD equals to A, so from this equation A equals to AD equals to AF, we conclude that AF also equals to A. AF also equals to A. Okay, then we joined points E and F together by a straight line, and we proved that those two triangles can go into each other. That is to say, the green triangle can go into the orange triangle. Why those two triangles can go into each other? First of all, we just right now proved that side AD equals to side AE equals to A. In addition, those two angles are both equal to 60 degrees, therefore they are equal to each other. And finally, we have side AE that is the common side, it belongs to both triangles, so this side equals to itself, so AE equals to AE. So we actually proved that those two triangles can go into each other according to side angle side rule. Those two sides and the angle between them in the green triangle can go into those two sides and the angle between them in the orange triangle. Therefore, those two triangles can go into each other according to side angle side rule. Okay. Triangle ADE, the green triangle can go into the orange triangle EFC according to side angle side rule. And from the fact that those two triangles can go into each other, we conclude that DE equals to EF. E equals to F according to the rule that corresponding sides in congruent triangles are equal to each other. D equals to F. But according to what is given us in the question, D equals to X. If D equals to X, and from this equation X equals to D equals to EF, we derive that EF is also equals to X. Here EF is also equals to X. Then we implemented the law of cosines in the right triangle EFC. Okay, but first of all, I presented to you what is the law of cosines. Here, the law of cosines is true in any triangle, so not here in any triangle. That is to say, triangle ABC could be any triangle. We know that in triangle ABC, side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. And the angle between side AB and side AC is theta. Then, according to the law of cosines, we will get that C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times AB times cosine theta. So we implemented the law of cosines in this triangle, triangle EFC, FEC. Here, side F equals to X, side EC equals to 5 units, and side EC equals to 4 units, and angle FCE, this angle equals to 30 degrees plus 30 degrees, that is 60 degrees. Here, side angle FCE, this angle equals to 60 degrees. So according to the law of cosines, we get that in triangle EFC, x squared equals to 4 squared plus 5 squared minus 2 times 4 times 5 times cosine 60 degrees. Again, x squared equals to 4 squared plus 5 squared minus 2 times 4 times 5 times cosine 60 degrees. So here, x squared equals to 4 squared. 4 squared is 16, plus 5 squared. 5 squared is 25, minus 2 times 4 times 5. 4 times 5 is 20, and 20 times minus 2 is minus 40. So in conclusion, this expression equals to minus 40 times cosine 60 degrees, and cosine 60 degrees equals to 1/2. So in conclusion, this expression equals to minus 40 times 1/2. Okay, so here x squared equals to 16 plus 25. 16 plus 25 is 41. And minus 40 over 2 is minus 20. So in conclusion, I found out that x squared equals to 41 minus 20, and 41 minus 20 is 21. So in conclusion, we found out that x squared equals to the positive root of 21 because of the fact that x is a length, it must be a positive number, so it is equals to the positive root of the square root of 21. So the answer to the question is that x equals to the positive root of square root of 21. In terms of numbers, it is equals to 4.58 square units. Here, x, the value of line segment DE that is equal to x, it is equal to either the positive root of square root of 21, or in terms of numbers, it is equal to 4.58 square units. So we finished with the first question, then I presented to you the second question. In the drawing, we have a quarter circle. This is a quarter circle. Inside the quarter circle, we have a semicircle, and the circle that are tangent to each other at point L. And this circle is tangent to the semicircle at point K. And our mission is to find out the shaded area, the value of the shaded area. So first of all, because of the fact that this is a quarter circle, it means that this point O, is the center of the quarter circle, and this angle COB, equals to 90 degrees. This is true in any quarter circle, and so here we have tangent OB is tangent to this circle at point M. Point M is the point of tendency of tangent OB with this circle. And we have the radius PM that is drawn to the point of tendency. And according to rule number 1, whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, according to rule number 1. So here, the radius PM, it is drawn to the point of tendency, that is to say, it is drawn to point M, that is the point of tendency of tangent OB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent OB will be perpendicular to the radius MP. So if OB is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. In the next step, from point P, we draw perpendicular on OD. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P in DO is S. Okay? So here, we created the quadrilateral SPOM. Inside quadrilateral SPOM, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees. So in quadrilateral SPOM, the sum of 3 angles is 270 degrees plus the size of the fourth angle that is actually SPM. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So we subtracted 270 degrees from this equation and found out that the missing angle SPM equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this is a right angle. Okay? So we actually found out that inside quadrilateral SPOM we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate it to quadrangle SPOM. We relate to quadrangle SPOM as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. So the opposite sides of a rectangle SPOM must be equal to each other. That is to say, side SO must be equal to side PM. SO equals to PM. According to the rule that the opposite sides of a rectangle are equal to each other, SO must be equal to PM. But PM equals to 2 units. It is the radius of the circle. So we can write here that PM equals to 2, and from this equation 2 equals to PM equals to SO, we will derive that SO also equals to 2 units. Here SO equals to 2 units. Likewise, side SP must be equal to side OM according to the same rule that the opposite sides of a rectangle are equal to each other. Side SP must be equal to side MO. And if we define side MO as X, here MO equals to X, then from this equation X equals to MO equals to SP, we will derive that SP also equals to X. Here SP equals to X. Okay. Then we know that this circle is tangent to the quarter circle at point K. At point K, we have an internal arch between the quarter circle and the semicircle. And whenever you have an internal arch between two circular shapes, then the straight line that joins their centers together must pass through the point of tendency of the two circular shapes. In this case, the straight line OP must pass through point K. Why? Because point O is the center of the quarter circle. Point P is the center of the circle. So the straight line that joins their centers together is OP. And according to the rule that I mentioned, the straight line OP must pass through the point of tendency of the two circular shapes. That is to say, it must pass from point K. That is to say, OPK is one straight line. Okay? According to the rule that I mentioned, OPK is one straight line. Or in other words, OK is a straight line. If OPK is a straight line, it means that OK also is a straight line. Point O is the center of the quarter circle. Point K is the point of the quarter circle itself. That is to say, OK is the radius of the quarter circle. OK is the radius of the quarter circle. So we define the radius of the quarter circle as capital R. Therefore, OK will be equal to capital R, according to our definition. It is the radius of the quarter circle. Here, point P is the center of the circle. Point K is the point of the circle itself. That is to say, PK is the radius of this circle that is equal to 2 units. So here we found out that PK equals to 2 units. OK is the radius of the quarter circle that is equal to capital R according to our definition. And what is the length of line segment PO? It is very easy to see from the drawing that PO equals to KO minus PK. Again, KO minus PK equals to PO. Again, PO equals to OK minus PK. OK equals to capital R, PK equals to 2. So in conclusion, we found out that PO, the length of line segment PO, equals to capital R minus 2. Okay. Then we implemented the Pythagoras theorem on the right triangle OPM. So I copied the right triangle OPM in a new page, and we implemented the Pythagoras theorem on this triangle, triangle OPM. This is, of course, a right triangle. Here we have triangle OPM. We have just right now found out that the hypotenuse OP equals to capital R minus 2. PM equals to 2 units. This is the radius of the circle, and OM equals to X. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OP square equals to PM square plus MO square. OP square equals to PM square plus OM square. OP equals to capital R minus 2, so OP square equals to capital R minus 2 square. It is equal to PM square. PM equals to 2, so PM square is 2 squared, that is 4, plus OM square. OM is X, so OM square is OM squared is x squared. So in conclusion, we found out that according to equation number 1, capital R minus 2 squared equals to 4 plus x squared. Here we open the brackets on this side of equation number 1, and we found out that according to equation number 1, R minus 2 squared equals to R squared plus 2 squared, that is 4, minus 2 times R times 2, that is minus 4R. So here, in this side of the equation, we have R squared minus 4, R squared plus 4 minus R. In the other side of the equation, we have 4 plus x squared. So in equation number 1, we have 4 on both sides of the equation, so 4 will get cancelled. What is left from equation number 1 after we cancelled 4? What is left is actually here x squared equals to R squared minus 4R. Okay? And here we have an external notch between the circle and the quarter circle. That is to say, they are touching each other externally, it's point L. And whenever you have an external notch between two circular shapes, it means that the straight line that joins their centers together, in this case is PH, must pass through the point of tendency. In this case, the point of tendency is point L. That is to say, PL edge is one straight line. I repeat again according to the rule that I mentioned. Whenever you have an external notch between two circular shapes, then the straight line that joins their centers together, here point P is the center of the circle, point H is the center of the semicircle. So P edge, so points P and H are the centers of those two circles and the semicircle, and the straight line that joins their centers together is PH, and this straight line, according to the rule that I mentioned, this straight line PH must pass for the touching point of the two circular shapes, that is to say for point L. That is to say PL edge is one straight line. Because of the fact that the straight line PH must pass for point L, it means that PL edge is one straight line. Okay, PL edge is one straight line, or if PL edge is one straight line, it means that P edge is also a straight line, of course. So here we know that point H is the center of the semicircle. Point L is a point of the semicircle itself. This is exactly the definition of a radius. That is to say, L edge is the radius of this quarter circle that is equal to 2 units. Likewise, we have P, point P is the center of the circle. Point L is the point of the circle itself. So PL is the radius of this circle that is also equal to 2 units according to what is given as the question. Okay? In conclusion, we found out that edge L equals to 2 and LP also equals to 2, and HP must be equal to edge L plus LP. That is to say, HP equals to edge L, that is 2, plus LP, that is also 2, plus LP, that is also 2. So HP equals to 2 plus 2, that is 4. HP equals to 2 plus 2, that is 4. And it is one straight line, of course. HP equals to 4 units. Then I drew the right triangle HSP in a new page and we implemented the Pythagoras theorem on the right triangle HSP. HP is one straight line, so it is the hypotenuse. That is equal to 2 plus 2, that is 4. The hypotenuse of the right triangle HSP equals to 4 units. We know that SP equals to X, and what is the value of side edge S? The value of side edge S is very easy to see from the drawing. It is equal to the radius of the quarter circle, that is CO, minus C edge, minus SO. Again, S equals to the radius of the quarter circle, that is CO, minus C edge, minus SO. Okay, CO is the radius of the quarter circle that is equal to capital R according to our definition. C edge, here C edge equals to 2 because of the fact that it's the radius of the semicircle, so it is equals to 2 units, minus OS, this is also equals to 2. So in conclusion, we found out that AJS equals to capital R minus 2 minus 2, capital R minus 2 minus 2 equals to capital R minus 4. So we found out that AJX equals to R minus 4. So we can write here that AJS equals to R minus 4. Then we implemented the Pythagoras theorem on this right triangle, triangle AJSP, according to the Pythagoras theorem. Here PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is HP square, and it must be equal to HS square plus SP square. HP equals to 4, so HP square is 4 squared, that is 16. HS equals to R minus 4, so HS square is R minus 4 square, plus SP square. SP equals to X, so SP square is X square. So here we open the brackets on this side of the equation. We have here 16 equals to R minus 4 square. R minus 4 square equals to R square plus 4 square, that is 16, minus 2 times R times 4, that is minus 8R plus X square. We have here 16 on both sides of the equation number 2, so 16 will get cancelled. What is left from equation number 2 after we cancel 16? What is left is, in this side of the equation we have 0. That is equals to R square minus 8R plus X square. We added 8R to this equation, equation number 2, and found out that 0 plus 8R is 8R. So 8R equals to R square plus X square. Because 8R minus 8R is 0. So in conclusion, we found out that 8R equals to R square plus X square. We subtracted R square from this equation and found out that according to equation number 2, X square equals to 8R minus R square. Okay, X square equals to 8R minus R square according to equation number 2. But we have already found out that according to equation number 1, X square equals to R square minus 4R, while according to equation number 2, we found out that X square equals to 8R minus R square. Then we created equation number 3 that states that X square according to equation number 1 must be equal to X square according to equation number 2. Okay, so X square according to equation number 1 equals to R square minus 4R. It must be equal to X square according to equation number 2, that is equals to 8R minus R square. So according to equation number 3, we found out that R square minus 4R equals to 8R minus R square. Here we added R square to this equation, equation number 3, and we found out that R square plus R square is 2R square. So in this side of the equation, we have 2R square minus 4R, that is equal to 8R. Here we added 4R to this equation, equation number 3, and found out that 2R square equals to 4R minus 4R is 0, so, and add 8R plus 4R is 12R. So in conclusion, we found out that according to equation number 3, 2 times R square equals to 12R. We divided this equation, equation number 3 by 2, and we found out that 2R square over 2 is R square, and 12R over 2 is 6R. So in conclusion, according to equation number 3, we found out that R square equals to 6R. We subtracted 6R from this equation, equation number 3, and we found out that R square minus 6R equals to 0. According to equation number 3, here we took R as a common factor from this equation number 3. So what is left from R square after we took from it R as a common factor? What is left is actually R. And what is left from minus 6R after we took from it R as a common factor? What is left is actually minus 6. So in conclusion, we found out that R times R minus 6 equals to 0. So here we have two solutions that are possible for R. The first solution is R equals to 0. But because of the fact that R is the radius of the quarter circle, it can never be equal to 0. It must be a positive number. Therefore, we left only with the second solution, that R minus 6 equals to 0. We added 6 to this equation and found out that R equals to 6. So we found out that the radius of this quarter circle equals to 6 units. And what is actually the area of this shaded shape. The area of the shaded shape equals to the area of the quarter circle minus the area of the circle minus the area of the semicircle. And repeat again, the area of the shaded area equals to the area of the quarter circle minus the area of the circle minus the area of the semicircle. We have already found out that the radius of the quarter circle equals to 6 units. Therefore, the area of the quarter circle will be equal to the radius of the circle over 4. That is to say, it will be equal to the radius of the circle equals to pi r squared. And when we divide it by 4, we get the area of the quarter circle. That is to say, the area of the quarter circle equals to pi r squared over 4. And we know that r equals to 6. And the area of the circle equals to pi r squared, and r equals to 2. Therefore, pi r squared is pi 2 squared. This is the area of the circle minus the area of the semicircle, and the area of the semicircle equals to the area of the circle over 2. R equals to 2, so the area of the circle is pi 2 squared, and if we divide it by 2, we get the area of the semicircle. That is to say, the area of the semicircle in conclusion equals to pi 2 squared over 2. So we already found out that the area of the quarter circle equals to the radius of the quarter circle equals to 6, and the area of the quarter circle equals to pi r squared over 2. R equals to 6, so r squared is 36. So in conclusion, the area of the quarter circle equals to pi r squared is 36 over 4, and the radius of the circle equals to pi 2 squared. 2 squared is 4, so this expression in conclusion equals, in total equals to 4 pi. Here we have pi 2 squared over 2. 2 squared is 4, 4 over 2 is 2. So in conclusion, this expression equals to 2 pi. Okay? This is the area of the semicircle. And we have 36 over 4 is 9, so in conclusion, in total, this expression equals to 9 pi. The area of the quarter circle equals to 9 pi, minus the area of the circle that is equal to 4 pi, minus the area of the semicircle that is equal to 2 pi, equals to, here, 9 minus 4 is 5, and 5 minus 2 is 3. So in conclusion, we found out that the shaded area equals to either 3 pi square units, or in terms of numbers, it is equal to 9.42 square units. I repeat again, this shaded area, the value of the shaded area, equals to either 3 pi square units, or in terms of numbers, it is equal to 9.42 square units. Okay, thank you very much.